Hello, party people. People who love to party. It's me, Mr. Bill, here to talk with you about completing the square. Now, completing the square is review from IM2, and it's a method for solving quadratic equations. And you should already know how to do it, but maybe you don't. And more importantly, I'm going to expand what we do with it. So let's begin. So we're going to start off with this, solve the following quadratic equation. As you look at this, you may notice that this is definitely factorable. If we were to factor it, it would factor into x minus 2 times x minus 4. And so our two answers should be 2 and 4. We straight up already know that, or at least you do now that I've said some words. What we want to do is practice completing the square with this thing. And how you've probably been told is when you complete the square, you got to get rid of this guy right here, minus 8. Move him over, which is crazy because normally we want that to equal 0. But you got x squared minus 6x is equal to negative 8. And now I need to come up with something that I can add to both sides that would make this side a perfect square trinomial. A perfect square trinomial is a binomial times itself. And the way I go about doing that is I take this middle term, b, I cut it in half, which will give me negative 3. And then I square what I get from there, which is positive 9. That would make this a perfect square trinomial. Check out what I'm talking about. Your perfect square trinomial in this case would be x minus 3, that thing that we got right here, times x minus 3, because negative 3 times negative 3 makes 9. X times x makes x squared. Negative 3 times x right in here would make negative 3x, and you'd have negative 3 times this x, making another negative 3x, which adds together to make 6x. It doubles that part, which I can write as x minus 3 squared is equal to, over on this side I've got 1. Now I've got to solve this the rest of the way out. X minus 3 squared is equal to 1. I'm going to square root both sides. Mr. Bill, why'd you write that twice? So that you could see my work and didn't get confused. I've got x minus 3 is equal to, this is the part that you're going to mess up. You're like, it's 1. It's plus or minus 1. We just square rooted both sides. Now we're going to add 3. Ugh, geez. X is equal to 3 plus or minus 1, which means x is 4. That's 3 plus 1. Or 2, 3 minus 1. There's our answers. We've completed the square. It's a method for solving. But what does that give us? Like, what does that mean when we solve it? Well, if you move on down to the graph, the 4 and the 2 are the roots for this graph, or the x-intercepts. We'd be at 2 and we'd be at 4. And then we would try to graph this thing, which is a parabola. We know it's a parabola because it's x squared. Now, we're used to graphing parabolas and cubic functions and all sorts of other things when they are in vertex form. And completing the square is actually how you get them into vertex form. It's just a little bit weird. And that's what's going to be super useful for us as we move on. So this is really in service to vertex form and making sure you can complete the square on anything. Let's go into that. We've got the exact same problem here, only instead of equaling 0, it says y equals. Now, there's a couple ways you can go about this. You can treat it like that y is a 0, which is kind of crazy talk, because it's not going to be 0 all the time. We can minus 8 from both sides. Got y minus 8 is equal to x squared minus 6x. And we are going to need to add something to both sides. Ooh, I didn't give myself enough space on this side. Tiny little places. From up top, that thing was plus 9 and plus 9. And the way I got that was taking this middle term, cutting it in half, and then squaring what I got. So there's my plus 9 and plus 9. On this side, I've got y plus 1 is equal to, this whole thing's going to boil down to x minus 3 squared. That's what it was earlier. But we're not solving this for a specific value this time. We're going to end up with an equation. And we want y to be alone, so we could subtract 1 from both sides, and now it is in vertex form. Yay. This isn't even the way that I do vertex form. The way that I do it is, you may notice that when you're going from, when you have both sides of the equal sign, you're adding that thing to both sides, adding it to both sides. I like to keep everything on one side of the equal sign, which means I have to do something different. if I'm using x squared minus 6x, I'm going to move that 8. And I'm going to make my 2 little dashes for the new stuff that I'm going to put in there. That new stuff, we know it's plus 9. But since I'm still on the same side, I get minus 9 right here. Mr. Beal, you're a wizard or possibly a ghost. I don't believe you. It's true. Look, plus 9, minus 9 would cancel each other out. So that balances this side. Over here, since we're moving it to the other side, whatever I do to one side, I have to do to the other. But if I just want to balance it out on this side, I just have to make opposites. Now I can write this out. This part is going to become x minus 3 squared. This part is just negative 1. Voila! We have our vertex form. Our vertex is going to be at 3, comma, negative 1. Ding! And we'll go up like that. Yeah! That looks pretty good. I'm pretty proud of myself. So that's our job, guys. We want to convert stuff into vertex form. I know you've seen it once, but I want you to try on these 3 problems that are underneath. I'm going to pause it, and then I will go through them with you. Actually, I bet I could do the work super fast with you. So there are the 3 problems. You can write them down, and I'm going to get to work because I do this so quick. I'm actually really good at this thing. Also, you know, I have a degree in math, and I teach this. So let's see, I have, what's that going to be, 5? 5 is what? 10 over 2 is equal to 5. Get out of the way. And 5 squared equals 25. So I need y is equal to x squared plus 10x minus 3. This is going to be plus 25 minus 25. I've got x plus 5 squared y minus 28. Ta-da! Told you I'd be fast. You can pause it too. You don't have to watch me do this. Let's see, I've got negative 8 over 2 would make negative 4, and I'm going to square that bad boy to get 16. So I want y is equal to x squared minus 8x plus 16 plus 24 minus 16 plus 16 minus 16. So x minus 4 squared. Let's see, what's this, plus 8? Ta-da, vertex form. And finally, see, let's write this part up first. Minus 2x, space, negative 7, space. It's like we got negative 2 divided by 2 makes negative 1, and negative 1 squared is 1. Plus 1, plus 1. Oh no, minus 1. Ooh. Got x minus 1 squared minus 8. Ta-da! Super quick. Didn't even realize it would be that quick, did you? You also could have paused it. Whoosh. Now onto the back, which is not actually on the back of the paper that I have. Ding, more difficult problems. This is tough because what I was doing there was with the optimal type of problem for completing the square. Now we have to use non-optimal problems, but we want to keep stuff in mind. If we're going to use opposite sides, we get to add both times. If we're using the same side, if we're trying to find vertex form, plus on one side, or plus 1, I should say, it's all on the same side, plus 1 minus the other. So for here, it's going to get messy. You're not going to like it. I need to move this 5. I've got x squared plus 7x, something right there, negative 5. Bam, I'm going to put that same something over on the other side. What's that something? Well, 7 divided by 2 is, I'm going to leave that as 7 over 2. I know you want me to turn that into 3.5. I don't want to do that. 7 over 2 squared makes 49 fourths. Yeah, I can hear you. Oh, 49 fourths. No, Mr. Bill, not a fraction. Just make it a decimal. I refuse. 49 fourths. So this side is now a perfect square. What? Yeah, think about it though. It would be x plus 7 over 2 squared. How is that possible? Well, I know this part and this part probably makes sense, but if I have 7 halves or 3.5 and I times it by x, and then I have another 3.5x, when I add them together, they're going to make 7. Yeah, I know, it's ugly. And then it's equal to, over on this side, we've got -5. If I convert that to fourths, that's -20 fourths plus 49 fourths makes 29 fourths. Oh, yeah. I'm gonna use a different color for this part because it doesn't look like I have enough room to do what I really want to do, which is write it again. Now what do I got to do? Square root both sides. We're gonna need to remember our plus or minus. Got plus or minus. Now, something that's important is if you take the square root of the quotient, that's the same as the quotient of the square roots. These mean each other in square root rules. So this is really gonna be root 29 over 2 is equal to x plus 7 over 2. Now, why was that so important? Well, if you look at our denominators now they are the same. And we are going to get something that looks like an answer that you would see in the quadratic formula. I'm going to minus 7 over 2 from both sides, and I get x is equal to -7. There's that -7 over 2, plus or minus root 29 over 2. There are our two roots. Ms. Bill, I don't like that. That's cool. So then let's do it so that we're not concerned about roots. And all we want to get is the vertex form of this bad mamma jamma. That would mean rewriting this as y is equal to x squared plus 7x. Remember, this is the same problem. So it's going to be faster because I already have all these numbers that I need. Space plus 5, space. And what goes in these two spaces? We're going to have a plus here, but we're going to have a minus right there to balance it out. This will be 49 fourths, and this will be minus 49 fourths. Ooh. Right here gets shut off, and you've got x plus 7 over 2, just like before. This is going to be plus 20 fourths minus 29 fourths. Still y equals. So y is equal to x plus 7 over 2 squared. Nothing changed. Nothing changed right there. But back here, oh, I said 29. 49 is going to turn into -29. I was skipping a step in my brain. Ding. There's your vertex form. It means that we don't have to put together this part to get the answer. But sometimes if you want the roots, you got to do that. If you just want vertex form, not so much. Okay, we got to do some more. And these are all going to be kind of tough, so deal with me. We've seen what happens when we have an odd B. What about when we have an A that isn't 1? Well, we for sure do not curl up into a ball and start crying. That is not our job right now. We can do that later. There's nothing stopping us from doing that later. Y is equal to, we're going to factor out that 2 from these two terms. So we're still separating that 3 out, go away. We're just going to do vertex form for this one. We've got 2 in parentheses, x squared plus 2x, parentheses, minus 3, and I'm still leaving space for those two things. And since they're on the same side, this will be plus and this will be minus. Now I'm going to complete the square inside of this bad boy. Take my 2 out. I've got 2 divided by 2, which is 1. I'm going to square that 1. That's still 1. So we're going to be adding a 1 right here, plus 1. And out here we're going to be minusing 2. Mr. Beal, you're a charlatan, and I will destroy you. What? What do you mean? Can you not see that this 1 is inside of a parentheses? This isn't just 1, it's 2 times 1. So this is really, in the end, were we to, multiply this back out, it's going to be a 2. That's on the outside, so I have to have minus 2 there. It can't be minus 1. I know, charlatan, I heard you. So this will be y is equal to 2 times x plus 1 squared. Looks like minus 5. So your vertex would be -1, -5. And this time that 2 is our horizontal. Actually, no, wouldn't it be vertical? Yeah. Vertical stretch. You guys don't believe me. You need to see that again, huh? Well, I don't know that I'm going to be able to give you a nice one again. I think we got to do a harder one. And that's what's over here. I'm going to split it up like I did this one. I'm going to pull the 3 out. I've got x squared plus 5x. That's what's coming from these two pieces right here. Leaving that space, minus 17, leaving the negative space. Gonna have a plus, gonna have a minus. Now I gotta complete the square. I can already feel the sadness. I can taste it like a starburst. 5 over 2, I'm gonna leave it as a fraction. 5 over 2 squared is equal to 25 fourths. Plus 25 fourths. And over here, 75 fourths. He's a witch! No, I'm not. 25 over 4 times 3 is going to be 75 over 4. Guys, you got to believe me. We can't just rewrite this over here. It's in parentheses. We got to do that times part to get it over here. That's probably the part that you don't like. I don't know. Maybe you don't like this whole thing, but you got to know how to do this. We've got y is equal to 3. X, let's see, look back here. It looks like it's going to be plus 5 over 2 squared. And now this hot mess right here. I don't even know. Let's see, 4 goes into 75, like, I don't know, a million times. Let's see, 72 and 4 would be 18. So it's negative 18. Jeez, that is a lot. So I guess it'd be negative 35 and 3/4. Or, let me get a calculator on this real quick. Let's see, 35 times 4 plus 3. Oh, that's hideous. See, that'd be 143 over 4. Yay. Okay, we got one more left. Just one more. And you got to imagine, if it's gotten more difficult on this one, and then even more difficult here, that this will up the difficulty level one more time. It will. It surely will. Feel free to remind it anytime. Heck, feel free to drop by during my Zoom call. Practically nobody does. Still getting paid. All right. We are going to factor out that 2. It's just we are going to encounter a host of problems as we do so. 2x squared plus 7 over 2 x. Yeah, I know what you're thinking and feeling. At least I think I do. All right, we're going to take this over here. 7 over 2 divided by 2 is equal to 7/4. 7/4 squared is equal to 49/16 plus 49/16. But over on this side, I'm going to do minus 49/16. Oh, yeah. Y will be 2 times x plus 7/4 squared. Gross. And over here, let's see, this would be 32/16. So 49 minus 32 is like 17, negative 17/16. Yikes. Look how much space I left, though. I thought I would need that space to help you guys. Looks like I didn't. All right. I'm going to pause it this time just so that I make this video shorter while you work on these bottom problems and try not to, self-destruct. Boom. A little bit of setup there for you. If you're looking for first steps on any of these should be your first steps. You're factoring out for these two guys, you're just moving the 4 over and setting up for here. Notice how my sign changed here because I moved it over to the other side for the 4. But on this one, these are both going to be pluses. This will be a plus and a minus. And this will be a plus and a minus. Oh, I forgot my little line. Now from there, you would divide 9 by 2. And then you'd square that. That's going to give you 81/4. Which is probably not what you wanted. 4 is really 16/4. So that'll be 97/4. Over on this side, you've got x plus 9 over 2 squared. I'm going to square root both sides. You're going to get x plus 9 over 2 is equal to root 97 over 2. Remember, I can break up this square root as the quotient of the square roots, not just the square root of the quotient. Some fancy math words for you. Throw the plus or minus sign in front of that bad boy, and then minus this 9 over 2 from both sides. Should have x is equal to negative 9 plus or minus the square root of 97 over 2. Implosion. Over here, we're definitely looking for vertex form. We're not finding the roots because it didn't equal 0. This is going to end up being 1, which means this will end up being 5. 5 times 1 makes 5. You've got 5 times x plus 1 squared minus 20. Oh, yeah. That's good. I'm doing great today. All right, and then this guy over here looks to be a hot mess, probably because of Dracula. See, 81 over 16, because 9 over 2 divided by 2 would be 9 over 4 squared, makes 81 over 16. Someone's not going to like that I didn't write all that down. I'm sorry, I only got so much space. 81 over 16. Oh man, this is terrible. Y is equal to 2 times, I don't know, Dracula again. Let's see, x plus 9 over 4 squared minus 12 sixteenths. Is there another way to, hold on, wait a second, no. 16 would go into 81 like 5 times with 1 left over. Ooh, so this is 17 and 1/5, because this would be negative 5 and a fifth. Since they're both negative, you're adding them to get to that 17, but I got to turn that into a improper fraction. I mean, I guess you don't. You know what? If you got this here, you'd be good. I'm going to turn it into an improper fraction because I'm an improper kind of guy. And that would not be 1/5. That would be 1/16. There we go. Little choppy today, but not too bad. All right, guys, I hope you have a good day. As always, stay safe out there. World crazy.